Chapter 10.
Preparation, properties and uses of compounds of groups 1, 2, 13, 14, 15. A. Compounds of group 1 element. First, sodium chloride, common salt or table salt. Sodium chloride is the most common of the salts of sodium. It is also called common salt or table salt or rock salt or even sea salt. Sodium chloride occurs abundantly in nature. Seaweed water contains 2.7 to 2.9% sodium chloride. Manufacture. Sodium chloride can be obtained from seawater. In hot countries like India, common salt is obtained by solar evaporation of seawater in shallow tanks having layer of clay at its bottom to prevent percolation of salt solution. Water evaporates, leaving behind solid salt. In cold countries like Russia, common salt is obtained by removing the water as ice. When the temperature falls, pure water freezes in preference to sodium chloride solution. Ice formed is removed and concentration of NaCl increases. When the concentration rises to 22%, no ice separates. Now, the concentrated NaCl solution is evaporated in big iron pans to get solid salt.
Purification.
To get pure common salt, impure salt is dissolved in the minimum quantity of water. Saturated solution thus formed is filtered to remove insoluble impurities. Hydrogen chloride gas is passed through the solution. Due to common ion effect, ionic product rises above the solubility product of sodium chloride and crystals of sodium chloride separate out. The impurities, being more soluble, remain in the mother liquor. The crystals of sodium chloride are filtered, washed and dried. Properties. First, it is a colorless crystalline solid. Second, melting point is 1074 Kelvin and boiling point is 1713 Kelvin. Third, it is soluble in water but insoluble in organic solvents such as benzene, alcohol, etc. Fifth, pure sodium chloride is non-hygroscopic in nature. However, ordinary sodium chloride is lightly hygroscopic due to presence of impurities of MgCl2, H2O and CaCl2, 2H2O. Due to this, common salt gets wet in rainy season. Uses. Sodium chloride is used, first, in the manufacture of NaOH, NaHCO3, HCl and Cl2. Second, as a food article and as a preservative. Sodium hydroxide or caustic soda, denoted by NaOH. Laboratory preparation. First, it can be obtained by the action of water on sodium or its oxide. The solution obtained by dissolving sodium or its oxide is boiled, filtered, and the filtrate is evaporated to dryness to get flakes of caustic soda. 2Na plus 2H2O on reaction gives 2NaOH plus H2. Na2O plus H2OZ gives 2NaOH. Second, it can also be obtained by treating sodium carbonate solution with lime. An aqueous solution of sodium carbonate is allowed to react with lime and steam is passed through the reaction mixture. Na2CO3 plus CaOH whole 2 gives CaCO3 plus 2NaOH. Manufacture. First, causticization process or the Gossage process. This process is based upon the reaction between suspension of lime, milk of lime, CaOH whole 2 and sodium carbonate. Na2CO3 plus CaOH whole 2 on reaction gives CaCO3 plus 2NaOH. Second, Lowig's process. In this process, a mixture of sodium carbonate and ferric oxide is heated to redness in a revolving furnace when sodium ferrite is formed with evolution of carbon dioxide. Na2CO3 plus Fe2O3 gives 2NaFeO2 plus CO2, 2NaFeO2 plus H2O, 2NaOH plus Fe2O3. The solution is filtered and evaporated to dryness to get flakes of sodium hydroxide. Third, by electrolysis of sodium chloride. Sodium hydroxide is mainly obtained by the electrolysis of an aqueous solution of sodium chloride or brine. During electrolysis, hydrogen is evolved at the cathode while chlorine gas is evolved at the anode. At the same time, sodium hydroxide is formed in the solution. Since chlorine reacts with sodium hydroxide solution even in the cold, forming sodium chloride and sodium hypochlorite, it is necessary that sodium hydroxide and chlorine should not come in contact with each other during electrolysis. 2NaOH plus Cl2 on reaction will give NaCl plus NaOCl plus H2O. To overcome this problem, three types of cells which are frequently used for carrying the electrolysis are: first, Nelson cell; second, Kastner-Kellner cell; third, Kellner-Solvay cell. First, Nelson cell. It consists of a perforated U-shaped steel vessel which serves as a cathode. Perforated steel vessel is suspended in a rectangular steel tank.
Purified brine solution is taken in the cathode.
A graphite rod dipping in brine solution serves as an anode. The steel cathode is provided with an inlet for brine and outlet for chlorine gas. The outer steel tank is provided with an inlet for steam and outlet for hydrogen. It is also provided with an outlet for sodium hydroxide near the base. On passing electric current, chlorine is formed at the anode and hydrogen at the cathode. Sodium is collected at the base of outer steel tank. The asbestos lining in the steel cathode prevents the reaction between Cl2 and NaOH formed during electrolysis. The reactions taking place are NaCl, Na positive plus Cl negative, almost completely ionized. At cathode, 2H2O plus 2E minus gives 2OH minus plus H2. Na plus OH gives NaOH. At anode, Cl minus minus E minus gives Cl. 2Cl gives Cl2.